In this lesson, we're going to look at the factored form of a quadratic function. When a quadratic function is written in factored form, it looks like this. Y equals a x minus r, and then x minus s. And these are brackets that are multiplying. So a times x minus r times x minus s. Each factor can be used to determine a zero of the function by setting each factor equal to 0 and solving. So what is a 0? Remember, that's another word for a root or an x-intercept. So all of those mean the same thing. Now, if a parabola has one or two x-intercepts, the equation of the parabola can be written in factored form using the x-intercepts and the coordinates of the other point on the parabola. Quadratic functions without any zeros cannot be written in factored form. The x-intercepts of the graph of the function are r and s. So that's one, and that's the other one. Okay. The formula for the axis of symmetry we can figure out by taking r plus s and divide that by 2. Okay, so it's like finding the midpoint between them. It is finding the midpoint between them, not like finding the midpoint. That's exactly what we're doing. The x-intercept, if you want to find the x-intercept, which is c, what you're doing is you're multiplying a times r times s. So if you're given the equation in factored form and you multiply the coefficient a and the roots r and s, then you'll find out the y-intercept. The other way is to substitute x as 0, and you'll end up saying you're doing the same thing. If a quadratic function has only one x-intercept, the factored form can be written as follows. So we can see there's a, but because there's only one root, you'll end up with x minus r times x minus r. And another way of writing that is x minus r squared. So because there's only one root, you don't have an s value as well, you only have the r value. Okay, let's see how this works with an example. So in example 1, it says, sketch the graph of the quadratic function. We have f of x is equal to 2 times x plus 1 times x plus 6. So if I wanted to rewrite that in our format, y equals, this is my a, x minus r, x minus s. Okay, so if we're looking at the form that we have at the top here, right, when I first gave that to you, the very top, you can identify the different pieces here. So what are my zeros? Well, my zeros are my r and s. So what is r equal to? R is equal to -1, and s is equal to -6. Now you might say, well, no, it's not. It's +1 and +6. But because the formula is actually x minus r, x minus s, essentially what's going on here in our question is it's x minus a -1, x minus a -6. And if you remember, if you have that double negative in there, that gives you a positive. So that's embedded in there, and that's where the plus is coming from, right? If we look here, those two negatives, that's where this plus is coming from here. Those two negatives, that's where this plus is coming from here. Okay, so when you have, you're kind of looking at the opposite sign. So when you have a positive there, right, a +1, a +6, your zeros are -1. How else can we look at this? Another way, which some students find easier, you're seeing that, well, if x plus 1 is equal to 0. Well, if I subtract 1 from both sides, that means x is -1, right? I'm just taking that set of brackets. And if x plus 6 is equal to 0, subtract 6 from both sides, so then x is equal to -6. So that's another way, which is a more common way, because sometimes it's confusing to just pick them out of the equation. But that's essentially what you're doing. You're saying that f of x is equal to 0, right? So if f of x is equal to 0, 0 is equal to 2 times x plus 1, x plus 6, right? The same way we did that when we were solving by graphing, but now, if that's equal to 0, that means that either this set of brackets is equal to 0 or this set of brackets is equal to 0, and that's what I have written out there. Okay, so however you want to look at that, that's how you get your zeros from there. Now, for your y-intercept, we said we multiply the coefficient a times r times s. Well, a in this case is 2, right? R is 1, s is 6, right? Or negative 1, negative 6. Multiply those together, and you get 2 times 1, that's 2, negative 2. Negative 2 times negative 6 is positive 12. So your y-intercept is 12. We have a coordinate plane here. We're going to put those zeros and our y-intercept on there, and then we'll keep going. So y is 12, or y-intercept is 12, so I'll put a dot up there. And then my zeros are at negative 1 and negative 6. Okay, so that's all we have. Let's figure out our axis of symmetry, the equation for the axis of symmetry. We have a formula up here, r plus s divided by 2. So let's do that. R plus s divided by 2. Negative 6 plus a negative 1, that would give me a negative 7 over 2, or a negative 3.5. So that's halfway between here. I'm not putting a dot there, I'm just going to put a tick mark there so I know when I do my vertex. Now, is it negative 3.5? Is it up high or down low? You can anticipate where it might be, but let's figure that out. So how do we figure out our vertex? Well, if we're given an x value, so given x is equal to 3.5 from the axis of symmetry, substitute into your equation. So our equation is y is equal to 2x plus 1 x plus 6. I just noticed I made a mistake up here. This is supposed to be a plus 6. Okay, we're going to plug in that negative 3.5. So y is equal to 2 negative 3.5 plus 1, negative 3.5 plus 6. Okay, plug that into your calculator, do your math, and you get y is equal to negative 12.5. So again, what did we do here? Okay, we took this negative 3.5 that we got, because we know that's the x value of our vertex, and we wanted to find the coordinating y value. So to do that, we took that same negative 3.5, doing really well with science today, negative 3.5, lost that negative 2, and plugged that into our equation for our quadratic, and got the corresponding y value here. So what is my vertex? My vertex is negative 3.5 and negative 12.5. So on my graph here, I'll go down to negative 12.5 and negative 3.5, and I could put in my vertex there. At this point, we can draw our quadratic. Okay, so remember when you draw your quadratic, you're going to hit those key points. You're drawing a smooth curve as best you can, and then arrows at the tops there. Okay, good idea to label your vertex. And we've already labeled our x-intercepts, zeros, roots, however you want to call those, and our y-intercept. Now that we have all that on there, what is my domain, my range? Or is it a max or a min? What is that value? So it's a good idea to try this on your own first, and then see if you get the same answer we have. So domain, because my arrows are going up and out, it's the out part we're worried about for domain, because it's our total amount of x values, right, that we're worried about. And in this case, the domain goes from negative infinity to infinity. For the range, you always go low to high, and for domain and range, but for range, we can see there is a minimum here. The lowest possible y value is negative 12.5. The highest possible y value, well, there's arrows there, so it goes to infinity. What kind of brackets am I using? Round brackets for infinity, because we can approach infinity, but we can't get to infinity. But negative 12.5 is a point that exists on our graph, so we use a square bracket there. Now this, I've already given it away. This is a minimum, right? There is a lowest value, and that minimum is at 12.5, negative 12.5. So minimum at negative 12.5. Okay, so we're bringing in the same things that we learned earlier, but we just have a new format for our equation. Can we get it into the old format? For sure we can, if we really wanted to. Let's have a look at example 2. Okay. Determine the equation of a quadratic function given its graph. So now we're working the other way around. So write the function in factored form and then write it in standard form. So in order to figure this out, we need to get all of our key points off of our graph. So if I look here, I'm going to start by finding my zeros. And my zeros are at negative 1 and 4. Why would I want to do that? Well, if this is in factored form, those two zeros, my r value and my s value, come right out of there. So in this format, a x minus r, x minus s, well, my zeros should represent my r and my s, right? So I don't know my a value, but I know my r value, x minus a negative 1 and x minus 4. Okay. Don't like that negative there, so I'm going to lasso those and change it to a plus. So y is equal to a x plus 1, x minus 4. Looks great. At this point you kind of feel like you're done, except for that a sitting there. Does that matter? Yes, it does. We need to get rid of that. How do we do that? Well, there's another key piece of information on my graph that's going to be very useful to me, and that's going to be my y-intercept. My y-intercept is at 12. Okay, so step 1 found the zeros. Step 2, use my y-intercept. My y-intercept is 12. How would I write that as a coordinate point? We did that in our last unit because we needed to use that value to substitute in. So that means we've got an x value of 0 and a y value of 12. Why is that useful? We're going to use this and substitute it into here. So that if we use any x and y coordinate, any one that we have on there, we'll get our a value. So could I have plugged in, I don't know, let's find another point. Could I have plugged in 3 and 12? Sure, that would have worked. You could take any point along the parabola and stick it into here. But why not choose the y-intercept? Because it has a 0, and everyone loves substituting in 0 for a value because that makes life easy, right? We always want to make life easy. So let's go ahead and do our substitution. So my y value is 12, right? I don't know my a value. My x value is 0, right? They gave me, well, we gave ourselves the roots there, the x-intercept. Plug in 0 here. Okay, so substituting in x is 0 and y is 12. So now I've done that, I can do the math. This stays at 12. A times 0 plus 1 is 1. 0 minus 4 is negative 4. So 12 is equal to negative 4a. Almost there. We just want to get that a by itself, and you should be able to see what to do next. Opposite operation, divide by negative 4. So a little bit more algebra here. A is equal to negative 3. Okay. So, why did we do that? Well, we had everything we needed for our equation in factored form up at this point here, right? But we didn't have the a value. Now that we have the a value, we can rewrite it. So therefore, our equation is y is equal to a, which is -3. I'm going to actually move this. I realize there's a b part to this. We'll move it over here. So therefore, our factored form is y is equal to -3. Oops. Back to the page we want to be on. Times x plus 1 times x minus 4. So a bit of algebra to get there, but no problem. Okay? So that's 1. 2 says write it in standard form, and in standard form you're just going to have to go back to your grade 10 FOIL. Okay? You're going to first outside, inside, last, multiply that out, and then you're going to have to distribute the -3. So I'm going to do that in the space here. Hopefully you have enough space. So start with the formula that we just figured out. -3, x plus 1, x minus 4. Okay. Distribute the x. So x times x. I'm going to leave the -3 coefficient. So first gives me x squared. Outside gives me, that's a negative in front of there, right? -4. -4x. Inside gives me a plus 1x. And last gives me -4. Simplify. -3 x squared minus 3x subtract 4. And now we're going to distribute this -3 all the way through. So y is equal to -3x squared plus 9x plus 12. And you've got your standard form. So whatever form you give or you use, you'll get the same shape either way. But different forms gives us different pieces of information nicely. If I look at our standard form, easy to pick out the y-intercept. If I look at the factored form, easy to pick out my roots. Okay? So depending on what you're actually solving, oops, I lost part of my equation, solving for, depending on how you're given the equation, you could figure out other pieces of information quite quickly. Okay? So here's another example, B. It says determine the function that defines this parabola, write the function in factored form, write the function in standard form. So I'm going to leave this one for you to do, and we'll start class tomorrow with that one to make sure that you fully understand how to get the equation from the picture. So thanks for joining me today, and I'll see you in class.